Hi, Professor. This is Monisha here, and this is recording for the assignment Computer Performance for the CISC course 530 Computing Systems Architecture. So for this, the problem one is we have been given three different processors P1, P2, and P3, which are executing the same instruction set. P1 is having a 3 gigahertz clock rate and a CPI of 1.5, P2 2.5 gigahertz clock rate and a CPI of 1.0, P3 4 gigahertz clock rate and a CPI of 2.2, right? So we have to find out which processor has the highest performance expressed in instructions per second. To achieve that, we can use this formula, which is CPI is equals to CPU clock cycles for a program divided by instructions count. So we know 1 gigahertz equal 10 to the power 9 hertz. So instructions count is CPU clock cycles divided by CPI. CPI here stands for clock cycles per instruction. Okay. So instructions per second for P1 will come to 3 into 10 to the power 9, which is the clock rate, right? Divided by CPI is 1.5. So both the denominations have been given. So based on the above calculation, we can find you can see that processor 2 is summing the result for processor 2's instructions per second is coming 2.5 into 10 to the power 9. That means processor 2 is having the highest value, which highest performance, right? Now for the second question, sorry. It is asking if the processors each execute a program in 10 seconds, then find out the number of cycles and the number of instructions. So we can use the same formula that we used before. For this clock cycles, the formula is CPU time into clock rate, right? So we can multiply the CPU time, which has been given as 10 seconds, into the clock rate 3 gigahertz for processor 1, 2.5 gigahertz for processor 2. For processor 3, it is 4 into 10 to the power 9, that means 4 gigahertz, right? So these are the three clock cycles of the three processors. Now, when we are saying number of instructions, we normally calculate instructions per second. So if you multiply instructions per second with the CPU time, right? So we will get the number of instructions. So we already have calculated the instructions per second here, right? If you multiply the CPU time, which is 10, right? 10 CPU 10 seconds as given in the question, we'll find the number of instructions. So using the same calculation, I computed the number of instructions for processor 1, 2, and 3. Okay, moving on to the third question, which is we are trying to reduce the execution time by 30%, but this leads to an increase of 20% in CPI. So the execution time is reduced by 30% and the CPI is increased by 20%. And we have to find out which clock rate should we have to get this time reduction, right? So to find out that, first we need to know, as we already discussed, CPU time is equals to CPU clock cycles for a program divided by clock rate. So CPU clock cycles is again equals to instruction count into clock cycles per instruction total divided by clock rate. So if the execution time is reduced by 30 seconds, that means the CPU the new value of CPU is equals to 30% less of the CPU old, that is equals to zero point 0.7 of CPU old, like 1 minus 0.3, 30 by 100, 0.3, 1 minus 0.3, that is 0.7. Okay, and CPI is increased by 20%, so it is 1 plus 0.2, that means 1.2 CPU of CPU, the older value of the CPU. So sorry, CPI it is, sorry, I'm really sorry, it is CPI. Now, CPU new equal to zero point 0.7 CPU old. So we'll put the formula here to calculate the clock rate, right? Because we know the instruction count is same, right? So we'll say that, okay, CPI new divided by clock rate new is equals to 0 0.7 into CPI old by clock rate old. So if we have to calculate the clock rate new, that means 1.2 by 0 0.7 into clock rate old. That makes it to 1.71. That is 1 minus 71 divided by 100. That is like 71% more than the clock rate old is the clock rate news value. That means you have to set the clock rate. We have to increase the clock rate by 71% to get the time reduction. Okay, so with this one, the problem one gets solved. Now moving on to the problem two. Here we have two compilers. The first compiler is having a dynamic instruction count of 1.0 E9. Now 1.0 E9 is 1.0 into 10 to the power 9. and compiler B is having an instruction count of 1.2 E9, which means 1.2 into 10 to the power 9. And compiler A is having an execution time, that is a CPU time of 1.1 second, and compiler B is having 1.5 second CPU time. Okay, now the question of is, find an average CPI for each program if the processor has a clock cycle time of 1 nanoseconds. 1 nanosecond is 10 to the power minus 9. Okay, so CPI, we have to find out CPI equal to CPU clock cycles for a program divided by instructions into cycle time. For compiler A, CPI equals to 1.1 seconds into, sorry, divided by the instructions we have got 1.0 E9, that is 1.0 and 10 to the power 9, into cycle time it is specified 1 nanoseconds, which is 10 to the power minus 9 seconds. So after computing we'll find the CPI is, or clock cycles per instruction is 1.1. Same calculation we'll do for compiler B, and the result is 1.25. Now moving to the second question here, assuming the compiled programs run on two different processors, if the execution time on two processors are same, how much faster is the clock of the processor running compiler A's code versus the clock of the processor running compiler's B code? So over here we are using the same formula again. CPU time equal to CPU clock cycles for a program divided by clock rate, where CPU's clock cycles per program is instruction count into CPI, keeping CPU time of both same, CPU new equal to CPU old, like, or CPU of processor 1 equals to CPU of processor 2, and putting the formula over there, we come to the conclusion that it is 0.73 times of the older clock rate. Okay, so that means 0.73 means 1 minus 0.73 is 0.27. If you convert to percentage, it is 27%. So clock rate is 20% slower than the new clock rate. That means the um, processor compiler A's clock rate is 27% slower than compiler B's clock rate. This will put as A, this I'll put as B. Sorry, because I used it from this for naming, so I didn't change it. Really sorry for that. Let me just change it. I'll do it later because I know that this video has to be for less than 5 minutes. Okay, moving to the third question, which is, a compiler is developed that uses only 6.0 E8, that means 6.0 into 10 to the power 8 instructions, and then has an average CPI of 1.1. What is the speed of using this new compiler versus compiler A and B on the original processor? The original processor had a clock time of 1 nanosecond. Using the formula of CPU time equals to instruction count into CPI into clock cycle time, we'll find that the new compiler is having a CPU time of 0.6 seconds. So 0.6 seconds means if I compare it with the compiler A, it is 1.1 by 0.6 is coming to 1.666. So it is 1.666 times faster than compiler A, and 1.5 seconds divided by 0.6, like the CPU time of compiler B divided by CPU time of new compiler, you will get it 2.27. Why we are doing the CPU time by divided by? Because performance is inversely proportionate to CPU time. So less CPU times means high performance, right? That's why new compiler is 2.27 times faster than compiler B. So with this are my two problems I have computed and saved in this Word document. I'll upload it. Thanks so much, sir.